Quantum entanglement. What is that all about? It turns out that reality is not what we all think it is. And basically, quantum entanglement is a concept that dates back in of the 20th century. Many of the people who have worked with that have been Schrödinger, obviously, the one who created the equation, the one that talks about the cat experiment, in which he states that when you try to measure very small particles, it's extremely difficult to pinpoint exactly where the particle is. And that has to do with the Heisenberg effect, or the uncertainty principle, which states that the moment that you look at a very small particle, microscopic, the moment you look at it, it changes position. So it's very difficult to pinpoint exactly where the particle is. This is called the uncertainty principle by Heisenberg. Another guy who worked on that was, well, it dates back to Planck, Paul Dirac, Schrödinger, as I have already mentioned, and then it goes back to Werner Heisenberg, and then Einstein obviously took part of the discussion. And basically, when he described entanglement, he said that it was spooky things happening at very long distances. What he actually meant is that some particles, what you do to a particle in one place, there's another particle exactly like that one, exactly the same, but it can be at, at they can be apart by millions of kilometers. And what you do to this particle impacts this other particle that is far away and far away, distant from each other. So it's quite an achievement because as time goes by, we begin to find out more things and more things about these things. So quantum mechanics essentially is the idea that uh, in the old days, electrons were described as having orbits, as if they orbited the nucleus of the atom. So, but it's very difficult to pinpoint exactly where in that orbit the electron is because of the uncertainty principle. In other words, the moment you detect it, it's no longer there. It's already gone. So it's quite challenging to work with such small particles. but if we, as I understand it, this alters our perception of reality. In other words, we're not what we're looking at is not exactly what we think it is. It's kind of an illusion because of these principles, and that Einstein predicted, for example, gravitational waves. Now people are working on finding out how to measure or how to simulate, even create gravitational waves. The same with Dirac. Paul Dirac is probably one of the most brilliant physicists who ever worked on particle physicals, and he is the one who created. Well, there's a constant called the a constant that he worked on, just like Max Planck. Planck also had a constant, which are numbers that are always the same. Like the value of the constant for gravity is 9.8 meters per square. Uh, what 9.8 kilograms per square meter, and that's Newton.